Practice quiz number 19. I got some information here with some graphs. It says the following graphs depict the magnitude of an electric field or the magnetic field in a region of space as a function of time. You can see that 3 graphs are electric field versus time, and 3 graphs are magnetic field versus time. We want to know which of these graphs represent a situation in which electromagnetic radiation, or EMR, would be produced. If you remember, we talked about 3 key words in the intro to electromagnetic radiation that we did earlier today. We said accelerating charged particles. That's the first key word, accelerating charged particles generate changing electric and changing magnetic fields that are perpendicular to each other and perpendicular to the direction of propagation of the wave. So 3 words, helps you to answer just about any question here. Accelerating charged particles generate changing electric and changing magnetic fields that are perpendicular to each other and perpendicular to the direction of propagation of the wave. Now, we look at these graphs. We want to know which ones generate EMR. We're looking for changing electric or changing magnetic fields. We can see that A has a changing electric field that would generate EMR. It's not a sinusoidal wave, but that's okay, it's still changing. This one, too, does not. That's a constant electric field. This is a changing electric field. So that would generate EMR. Nope, constant magnetic field. Yes, changing magnetic field. And yes, changing magnetic field. So we're looking for 1, 3, 5, and 6. The answer would be D for this one. Any electric or magnetic field that is changing generates electromagnetic radiation. 2, a strong or intense source of gamma rays would most likely indicate, remember we learned that accelerating charged particles generate every type of EMR, but more specifically, we learned that nuclear decay or radioactive decay, matter being converted into energy, is the most likely source of gamma rays. Matter converted to energy. Is our answer for that one. 3, the relative direction of the electric and magnetic field components of the EMR radiation is, listen, I told you guys in the last unit, if you have to guess a direction in the magnetism unit or the new unit EMR, you're going to guess perpendicular. But we know the answer for this is perpendicular, right? Accelerating charged particles generate changing electric and changing magnetic fields that are perpendicular to each other and perpendicular to the direction of propagation of the wave, the direction of motion of the wave. So both of those are perpendicular. The answer is going to be D. And finally, number 4 says, which of the following sets of EMR is arranged in order of increasing photon frequency? Increasing frequency, that's the way that we learned the spectrum, right? So we've got radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Looks like B would be our answer here. We're skipping a few there, but of the ones that are listed, radio waves, ultraviolet, and gamma rays would be in the right order. You got to be careful here, because A, if we were asked for decreasing frequency, A would be the correct answer. Or if we were asked for increasing wavelength, then A would also be the correct answer. Wavelength is inversely related to frequency. So if A is decreasing frequency, it would be increasing wavelength. Answer for this question is B, though.